Hey ChemStars, it's Ms. McCauley here, and we're going to be going over the solutions, get it? Solutions to the Glencoe Virtual Solubility Lab today. Okay, so how do you find all the resources? In our PowerPoint, I have a link to the lab worksheet, so if you didn't get a paper copy, you can pull up a digital copy and print it at home, or just copy the questions onto scratch paper. You can click right from that copy, or you can click here on the slide. This will link you to the Glencoe Virtual Solubility Lab, and it has some fun sound effects. So if you're watching this video, I'm going to be going over the solutions. So right now I'm actually making the video for help graphing and answering questions. To get started, I have a really short 5-minute video that you can watch here to show you how to get everything done. Okay, so you should have already read through all the directions. I covered the procedure. And you should have made a hypothesis before you start. If your data table is blank, I want you to stop this video, go back and watch the procedure video. I want you to get all that data yourself, okay? So once you've got this filled in, you can come back to our video and check your numbers. Good. So on all of these, as long as you're within a gram of me, that's totally fine. It's kind of unclear whether you want to have right before or right after the solution settles out. You kind of actually want to be in between. Right before 1 more gram would make it settle. So if you've got 30 or 31, fine. All these numbers, if you're within 1, totally fine. So here's all my data. If you have any that don't match up, just make sure you go back to the lab site, click on the correct salt, and change the temperature, okay? And just make sure that you get the same results as me. So let's go ahead and look at how we want to graph this. Okay. So the directions say plot temperature on the x-axis. So plot temperature. And in our lab, that was all degrees Celsius. So we're going to put degrees Celsius temp. And we know that that temperature goes from 0 to 100. So let's count how many boxes we have. We know that this has to be 0. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16. Okay, so what do you think we want to make each box? We could make each box 10 degrees. We have some extra boxes. Or here's a trick. So if we take our calculator and we take 100, divide it by the number of boxes, we can say that each box would be about 6. Well, do we want to do that? That'd be kind of a weird graph. What if we made each box 5? So 5 and there's 15, we'd only get to 75. So it looks like we'll have to make every box 10. If you want something weird like making every box 6, you could, might just be hard to keep track of. So let's just make every line here 10. And we have to have 20, 60, and 100. So here's 0, here's 10. Now right here is 20. Oh, I should have left myself some more room. So right here, this is our degrees Celsius. So then there's 20. So this is 30, 40, 50, 60 is going to have a data point, and so is that 20. 60, 70, 80, 90, and then 100. Okay, so that's our x-axis. We've got all those values. So these are all going to be x values. And then on the y-axis, we need to plot the solute per 100 grams of water. So grams of solute. So let's label that grams of solute per 100 grams of water. That's just telling you that we were using this one same volume of water. 100 mils, think back chapter 1 and chapter 2, that is 100 cubic centimeters. That's 100 grams of water. Okay, so what do we do about the scale on this axis? Well, our smallest number is 3, so we got to start at 0 anyway. So we'll just put our 0 on here. But then the biggest number I have to get to is 181. And we have some other big numbers like in the 100s up here too. So let's take a second and count how many squares there are, how many blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, here's 20. We have 22 squares here. So if we take our calculator again, and we have 181, what if we divide that by 22? I can make each block like 8. Well, that doesn't sound very good. I'll probably end up making each block 10. So if we had 22 and we made each block 10, we'd get up to 220, and I'd be able to get our data there. But if we have 22 squares and we made each block 5, we only get up to 110. We wouldn't be able to graph some of these bigger numbers. So looking at that, let's just make every block 10. So here when I had said this is the 10th block, this is actually going to be 100 grams. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. Here's 150, 160, 170, 180, 190, 200. And then up here, that's going to be 220, but we don't even really need that number. Okay, so that's all of our axes set up. So how are you going to plot the data? Make sure you color code it. If you don't have different colored crayons, pencils, markers, pens, use some kind of symbol. Maybe use, like X's on the line or dots on the line or like slashes on the line, something that we can tell these apart. So I'm going to help you get started. So for our values here, the x-axis has the temperature. These are going to be my x values, and this is going to be my y coordinate. So for my first point, I've got a point at 030 for NH4Cl, ammonium chloride. So let's put a point at 0 degrees Celsius and then 30 grams. So 10, 20, 30. That's my first point. My next point is going to be at 2038. So here's 20. Okay, here's 30, here's 40. I'm going to make my best guess for where 38 is. That's good enough. And then we've got 60, 56. So here's 60. Here was 50, 60. Now 56 is going to be a little over halfway through. So there's 60 and 56. And my last point is going to be 100 degrees and 78. So 100 degrees. Now here's 50, 60, 70. And we needed 78. So right about there. Okay. Last thing we want to do is we want to make a trend line, a line in best fit. And we kind of want to, if there's a little bit of a curve, that's fine. Some of these aren't linear, they're more exponential. So we're going to connect our points to the smoothest line we can. And it looks like it's kind of trending up. It's not quite linear, there's a little bit of an exponential curve there. So I've done the first one for you. If you're good, you can pause the video, graph all these on your own and come back, fast forward to the end. If you're having a little bit more trouble, stick with me and we'll graph these things together. Okay, so now we've got barium hydroxide. So remember, our X value is going to be 0. Our Y value here is going to be 3. So we've got to put a point at 0. Now here's 10. Here's about 5. So 3 is going to be way down here by the origin. Then we've got 20 and 5. That's an easier point to graph. Then we've got 60 and 22. Here's 20. 22 is probably right about there. And then when we get to 100, all of a sudden we can dissolve 102 grams. So we've got some exponential growth here. So 100, there's 100, 100, 102 is close enough. So on this one, we really want to show this exponential growth curve. Now, what do you think? We should extrapolate this line out. What's going to happen as temperature continues going up? It seems like we're going to really have like an exponential increase here. Okay, maybe we will, maybe we won't, but that's what our data is showing us so far. So that's barium hydroxide done. Now let's graph our results for copper sulfate. So our first point is 0 and then 24. So here's 0, 10, 20, 24 is a little under half there. Then we've got 20, 33. So 30, 33, good enough. Then 60, 62, 50, 60, 62, and then 100, and then 115, 100, 110, 120, here's 115, right in the middle. Then try and do a smooth line of best fit, and we're going to extrapolate out what we think is going to happen. Ooh, make your lines better than mine. It's a little hard on my laptop, on my computer here with the smartboard. Try and continue that trend line. Okay, now let's look at the KCl, potassium chloride. So points here are 0 degrees, 29 grams dissolved. So here's 10, 20, so this line's kind of overlapping right here. Then we have 20 degrees, 35. So 10, 20, 30, 35. Then we have 60, 47. So here's 40, here's 50, 47, somewhere right about here. And then we have 157. So 150, 60, 57 is probably right about here. So this time our line's looking a little more linear. We extrapolate that out, something like that. One more to go. Sodium nitrate, the most soluble compound we have here. Sodium loves to dissolve in water, and anything with nitrate loves to dissolve in water. You put them together, you get really, really high solubility measurements. So sodium nitrate, 0, 74. So 50, 60, 75, 74 should be right about here. Then we have 20, 89. Okay, here's 2090, so just a shade below that one. Then we have 80, 60, and 123. So 60, 100, 110, 120, 123. And our last one here, 100, then 181. So here's my 100 line. 150, 160, 170, 180, 181. Okay, now we're going to connect those. Starts linear, but then we just get a little bit more. Oops. Okay. Make your line better than I made mine. Let's try that again. So kind of linear, but then it seems like maybe it's speeding up a little bit of increase there. That's our graph. So you should have used different colors, or you could label the line or put different patterns on the line. So let's just take a look back at our hypothesis. I made a hypothesis that said, I think that the hotter the water, the more stuff that will dissolve. Look at my chart. Is that true? Seems pretty true. It's true for all the salts we have. If you've been going along with all the homework and the notes, you'll see some salts actually show a decrease in solubility, or things like sodium chloride table salt are a lot flatter and kind of just stay the same. So for me, I would say, oh, I was correct, because now make sure you write something here. Tell me why. Use good scientific language. Say, for all of my examples, as temperature went up, the amount of grams increased. For example, ammonium chloride went from 30 to 38 to 56 to 78. Some increased linearly, some increased exponentially. And then move on here. In conclusion, temperature and saturation of a solute. I want you to use some of your good math words like proportional, inversely proportional, directly proportional. They correlate. Try and think about how you can use some good general math words here. Okay. When we finish this, though, we've got to go back to the first page and answer those questions. So on the first page, it says, how many grams of sodium nitrate, that's the last one we were using, sodium nitrate, will be required to make a saturated solution at 80. So here's what we can do. We want to find 80 on our graph. So here's 80. And we want to find where that intersects with our sodium nitrate line. So if we look right here, let's see, why can't I see all my colors? That's the same one. So what is the value right here? We didn't actually solve for this in the lab, but you can see it intersects pretty clearly at 150. Whoa, I don't know why those check marks showed up. That was cool. So right around 150. So for the answer of this one, for the first part, it should be approximately 150. Depends on how well you made the line. Okay. Now they want to know about KCl. So KCl, potassium chloride, they say if 33 grams of KCl are added to 100 grams of water at 60, is it saturated, supersaturated, or un? Whoa, hold on. I turned on some kind of like predictive text thing. I got to turn that off. I don't know what happened there. Okay, and we're back. I think I fixed it. So if 33 grams of KCl are added to 100 grams of water at 60, is it saturated, supersaturated, or unsaturated? So let's look at our graph and kind of think back to our notes. We'll just pick one of these lines to look at here. So remember, this is the saturation point. So if anything is on this line, it is saturated. If we are below the line, it's unsaturated. That means that the solution could hold more. And if it's above the line, it's supersaturated, or you also could say oversaturated. Okay, so that's what we're looking for. We're going to look at that point, and we're going to see, is it on the line, above the line, or below the line? And so for KCl, they want to know 33 grams. Now, it's 100 grams of water. That's standardized from the experiment, 60 degrees. So 33 and 60. So let's find 60. So here's 60, 10, 20, 30, here's 33. So what are we? Are we above the line, below, or on the line? We're definitely below the line, so we are unsaturated. So for this part, we're going to say it is unsaturated. Now they want to know about barium hydroxide. So barium hydroxide right here. And the question says, if 75 grams of barium hydroxide were added to the 100 grams of water, that's just the same thing we've been doing, at 20, is it saturated, super, or un? Okay, 75 at 20 degrees Celsius. Look at your data table. 75 at 20 degrees Celsius, where do you think we're going to be? Probably way over that line. So here's 20, here's 50, 60, 70, Here's 80, here's 75. Look at that line. We are way above it. So we are oversaturated. We are super saturated. It will not dissolve. Okay? So at this point, you should have had your data table filled out, done your graph. You should have these answered. Okay? Use your good math terms, and we worked on those questions together on the front. Great job. See you next time, guys. Bye.